All right, we should be recording now. So hi everyone, my name is Sierra. I am the stats tutor for the College of Health and Human Sciences Student Success Center. So today we are doing the mid-semester review workshops. We're going to be covering a worksheet that I have pre-made, and then at the end, hopefully there will be enough time for questions if anyone has any questions. But if there are additional questions or questions on something else that you wanted to go over, you can make an appointment with me. I have the instructions on how to make the appointment on this slide. Yeah, so let's go ahead and get started. Does anyone have like any questions before we get started? Just to make sure. Okay, so we're gonna start with just a quick poll that's kind of just trying to gather what class you are in. So I just launched that if you guys want to answer. Okay, wow, looks like everyone is in Stat 95. Awesome. Sounds good. Okay, let's go ahead and get started. So there's going to be poll questions like randomly throughout the workshop just to keep everyone engaged and for you to have an opportunity to check in and make sure that you understand what's happening. If at any point I am going too fast or you have a question, feel free to unmute or just say it in the chat. I'll slow down or answer whatever question you might have. So a lot of this I'm going to be asking for your guys's help, like just to answer the questions. Don't be afraid to answer, even if you think you might be wrong. That's the best way to learn, is to try. So yeah, let's get started. So here's the first page. So we're going to start with just writing out the formulas. So can anyone tell me what the formula for variance is off the top of your head, if you know?
Isn't it just standard deviation or squared? Or is that something different?
Yes. So yes, technically that is correct. Good. So I'm just going to write that. So variance is equal to the standard deviation squared. Good. So does anyone know what the long equation is? I know it's a pretty long equation. It's kind of hard to just memorize like that. Well, I just saw a question in the chat. Will you share that document with us? Yes. So if you fill out the survey, I'll get your email and I'll send you a copy of the blank worksheet, the answer key, and everything that we write down today. You'll get 3 copies of it, I guess. Okay, so I'm going to write the equation for variance. So it is the sum of x squared minus the sum of x in parentheses squared divided by n. And then that whole thing is divided by n. Does that equation look familiar to you guys?
Yeah. Okay. Yes.
Yeah. Okay, good. I'm glad to hear that. So this would be the formula for population variance. So can anyone tell me how it might be different for sample variance?
N-1 at the bottom, at the very bottom.
Good. Yeah, good job. Okay, let me write that. So sample would be the same thing. So the sum of x squared minus the sum of x in parentheses squared divided by, so it's going to be uppercase N now, right? And then it would be N minus 1. Good. So there oftentimes there's a lot of confusion between what the difference between this and this is. Can anyone explain what the difference between those are?
The one on the left is, I think, you add all of them and then you square, and then that one is like you square each one of them.
Good. So it's actually the opposite of what you
The
said,
opposite.
but so I'm gonna write it out. So thank you for answering. I appreciate it. So sum of x squared, so this one is where you square them all first. And then you add them all up. And then this one, the sum of x squared. So you add first. And then square that number. It's just one number you square. Does anyone have any questions on that part? No? Okay. So I'm gonna move on then. Okay, so can anyone tell me what the equation for standard deviation is? No? Okay, that's okay. So it's pretty much the exact same thing. You just put a square root over it. So it's equal to the square root of variance. So if we want to write it out long ways, would just be like the exact same thing, just with the square root on top. And then the same thing for population. So this one is population, and then the next one, we want to do the sample. Divided by n, and then the whole thing divided by n minus 1.
Can you kind of like explain the difference between variance and standard deviation?
Yeah, so standard deviation is like how many or how far away from the mean a score is. So if we were to look at like a bell curve, I'm going to draw it right here on the side. So if we wanted to look at a bell curve, kind of like that, let me draw this straight line. Okay, so let's say this is the mean. So a standard deviation, so this would be one standard deviation away, this would be 2, this would be also 1, but to the left, so we would say negative and negative. So one standard deviation away, so this would be a standard deviation. So everything that, so it's basically just how far away from the mean a score is. So it's just a set number of how far away it is, I guess. I don't know if that makes sense or if that answers what you're asking, but
Yeah,
yeah.
that makes sense. I think what I meant was like the difference between those two. They like seem similar, but it's like hard to kind of.
Like the difference in the formula or just like the difference in general?
The difference in general, are they like the same thing?
Yeah, so they're pretty similar. Variance is just like, I'm trying to think of a way to say it without like saying the same words. But like variance would be like the difference in variability, which I know is like the same word. So it's like trying to think of a way without saying the same word, but I can't right now. I'll come back to it if I can think of a way to say it without a word or without using the same word. But variance is basically the variability between the scores. And then the standard deviation is like how far away a score is from the mean.
That makes sense. And that's the sample mean in the middle, like the sample mean or population mean.
Yeah. Okay. Cool. Thank you for asking that question. I appreciate the questions. Okay, so let's go to z-score. So can anyone tell me what the formula for a z-score is? This one's a little bit easier than the variance and the standard deviation. Okay, that's okay. So it's just the score. So x would just be the score minus x bar, which means the mean, all divided by the standard deviation. So if I'm saying standard deviation, I'm just gonna abbreviate for SD. So I'm gonna write that right here, just so it's clear. Every time I write that, I'm just gonna put SD for standard deviation. Okay, does anyone have any questions on any of the formulas or anything like that before we move on? Okay. Awesome. So let's move on to this. So this is going to be our first poll question of finding the mean. So this is a population sample. So let's go ahead and find the mean. Let me start the poll. And then I'll have you guys calculate it and pick what answer you get, and then we'll go over it after. We'll give it like 20 more seconds.
Can you scroll up for a little bit, like for the z-score?
Oh, yeah. Sorry.
Okay, I got it. Thank you.
Yeah, I'll just stay right here for a bit. Like right there. There we go. Okay. I'm gonna end the poll. Looks like everyone got it. So can anyone explain to me what they did in this problem?
I added all of them and then divided by the number of samples. I mean,
Perfect.
samples there are, so that's 6.
Good. Okay, so what did you get for the total number? Thank you, Brianna. I saw your chat as well. What'd you get for the total? Anyone?
I had on my calculator.
62.66.
Good. So when you add up all the scores together, what did you get? Just
376.
good, 376. And then how many scores? Anyone were there? 6. Good, thank you. So 376 divided by 6 is 62.67. Perfect. Does anyone have any questions on that? I believe everyone got it right, but if anyone has any questions, feel free. Okay. So let's do our next one. So we'll do the range. So go ahead and try that now.
Poop. I misread it, or I forgot.
Oh, it's okay. No worries.
It's 70 instead of 71.
No worries. Okay. We'll give it like 15 more seconds. All right. So let's go over that one. So can anyone tell me how to find the range, like in general, without using the numbers, just in general, how do you find the range?
Maximum versus minimum.
Good, okay. So what's the maximum number in this set?
71,
71, good. And what's the smallest, the minimum?
56.
Good, so 71 minus 56 is 15, right?
Mhm.
Okay, does anyone have any questions on the range? Before we move on? No? Okay. So now let's find the variance. Is it okay if I scroll past the formulas now? No objections, okay. So let's find the variance. I'm actually gonna erase this bell curve because I will need all of that to write. I can rewrite it later if anyone needs it. Okay, so let's start with the variance. So we wrote our equation already. So we said, well, let's say this. So it's the population. So should we use n or n minus 1 on the bottom of our equation?
And
N, good, thank you. So the sum of x squared minus the sum of x squared divided by little n. So little n is population divided by n. Perfect, okay. So let's do everything step by step. So let's start by finding this first one first. So the sum of x squared. So can anyone remind me of how we would find that? Like what were the steps that I shared earlier? Or if you have your own way of thinking of it.
Square first, then add.
Good, so we want to square all our numbers first and then add them. So I know this is going to take you guys probably a while to plug it into your calculator, but if you guys want to do that and tell me what number you get, and then we could do that.
And then the sample was n minus 1, right?
Yes, sample would be n minus 1 on the bottom, and it would have a capital N. So if they don't tell you necessarily that you want to do population or sample, capital N would be sample and lowercase n is population. So in case they say like n is equal to some number, that would be a sample. But if they said lowercase n is equal to some number, that would be population. In case they like just give you numbers and say find the standard deviation or something, that would be how you could tell the difference. Okay, does anyone have a number yet for the sum of x squared, the first one?
I had one more question.
Yeah, go ahead.
For the, those Eve looking things
Yeah,
at the beginning, what does that mean again?
that just means the sum of. So that just means you're adding everything together. So like for the one we're doing, that stands for adding together all of the squared numbers. And then for the second one, that stands for adding together all of the numbers.
Okay, gotcha.
Good questions, good questions. Don't be afraid to ask a question because I'm sure someone else is thinking the same thing as you. Okay, does anyone have a number yet? Or does anyone confused on how we would find it? $2,300 good, good. That's what I got as well. 23,766. Perfect. Okay. So let's do the second one. So the second one would be the sum of x squared. how did you get the x? Okay, let's go over it. So let's rewind. So let's solve for that. So let's rewind. Let me get a different color out. Okay. So the sum of x squared. So let's write step by step what we want to do. So someone shared that we should square all the numbers first and add them up. So we would do 56 squared plus 59 squared plus 71 squared plus 62 squared plus 70 squared plus 58 squared. So that's what we would plug into our calculator to get that answer. So when we plugged it in, I believe Sarah got 23,766. Does that make sense? Does that answer your question? Or does anyone else have any questions about that? Okay, awesome. So let's do the next one. So let's do a different color. So let's do the sum of x squared. So what we want to do for that is to add them all up first. So 56 plus 59 plus 71 plus 62 plus 70 plus 58. So can anyone plug that into their calculator and tell me what they get?
Wouldn't it be 376?
Yes, good. I was gonna say 376. So the next part we need to do is square that number. So 376 squared. Can anyone tell me what that is?
It's 141,376
Good, perfect, yes.
number.
Yes, it is a very big number. Okay, so we got that. We just need to find one more thing before we can plug it into our equation. So n. Can anyone tell me what n would be equal to? Or what does n mean? Like without numbers, what does n stand for? Like the definition of n, I guess.
The amount of samples.
Good, yeah, so it's the amount of numbers in our sample. Perfect. So can anyone tell me how many samples are in this problem, this example? Good, 6. Perfect. Okay, now we have everything we need, so we can plug everything in now. So let's do that. So the variance is equal to, so we said that the first x, the sum of x squared, was equal to 23,766 minus, so we said that top x was 141,376 divided by n, which we said was 6. And then we divide that whole thing by 6. Okay, does anyone have any questions of how we plugged everything in or how we got here? Okay. Perfect, so let's move on. So let's just solve for this part first. So can anyone tell me what 141,376 divided by 6 is?
I got goodness, 23,562.67.
Good, yes, thank you.
I rounded up, so in case
Yeah,
anyone.
perfect. Yeah, we'll just round to 1 decimal place for this one. Thank you very much. Okay, divided by 6. So now let's subtract the top. So can anyone tell me what those two numbers subtracted are?
Uh, 203.4 is what I got.
Good, so 203 point, we'll just say 203.3. Divided by 6. Good. Thank you, Sarah, in the chat as well. Okay. Can anyone tell me what the last numbers are? 203.3 divided by 6.
33.9.
Good. 33.9. Perfect. So that's our answer. 33.9. Let's highlight it so we know it's the answer. Okay. Does anyone have any questions of how we got there or any of the steps before we move on? Because on the next one, I'm going to have you guys try it on your own. So hopefully you guys will be able to do it. So if you have any questions, ask now before we try.
So for the standard deviation, would we just square root that answer?
Yeah, perfect. So yes, let's move on. So basically standard deviation is equal to the square root of variance. We don't need to plug in everything all over again. We did it once, we don't need to do it again. So just be the square root of 33.9. If anyone wants to plug that into their calculator and tell me what they get.
Uh, 5.82.
Perfect, yes.
Okay.
5.2, yes, and thank you, both of you in the chat for saying your answer. Okay, perfect, 5.82. So does anyone have any questions on that before we move on? Because the next one you guys are gonna do all on your own. No, okay. Okay, let's do the next one. So it cut off a little bit, so I'm just gonna rewrite this at the top again. So we change, so it's gonna be a sample one this time, so make sure you pay attention to that N. So it's a sample and the numbers are 10, 12, 16, 13, and 19. Okay, so don't forget that it's a sample, okay? So what does that mean? Can anyone tell me what that means?
You're gonna do n-1 at the bottom.
Yes, perfect. Okay, so let's start with the mean. So that one's good. These are all going to be poll questions. By the way, these are anonymous polls, so I'm the only one that can see it, and I don't know who's responding. So, oh, sorry. Did you have a question?
No, yeah, so last when we just did, those are populations, like each individual score was like each population, I mean each sample, each of them was a sample for a population.
Yeah, so the difference between a sample and a population, so the population would be like, say you have 100 people in a room. A population mean or the population sample would be that you got surveyed every single person in that room. So for our case, there's 5 or 6 people in the room. We surveyed all 6 people. So for the next one, there's 1, 2, 3, 4, 5. So in this one, the example would be there's 20 people in the room and we only surveyed 5. So that's,
Okay.
does that difference make sense?
Yeah,
I get it.
I meant like the last one, there's like different numbers. So those are like different samples for a population.
Yeah, different samples for a population.
Okay,
Got you.
Yeah, of course. Okay. Sample mean. So I'll give it about like 20 more seconds. Okay, perfect. So looks like everyone got it right. So good. Okay, so can anyone tell me what the top part of the fraction would be when you add them all up? What did you get?
70.
70, good. And then what was N? I know I kind of already said it, but what was N? Or how many are in this sample? Or yeah.
5.
5, good, okay. And then 70 divided by 5, everyone got that right, which was just 14. Okay. Does anyone have any questions on that? Okay, awesome. So let's move on to the next one. So let's find the range. I'll start the poll. Let's do the range. Oh, everyone's ready. They already calculated it. Cool. We'll give it like 15 more seconds. All right. Cool. So everyone got it right again. So to find the range, we just do the biggest minus the smallest. So can anyone tell me what the biggest number was? 19. Good. And then the smallest number. 10. Yes, thank you. So 19 minus 10 is just equal to 9. Okay, perfect. So let's do the variance. Let's see if you guys mastered variance. All right, let's see. We'll go over it too after, just so everyone knows, but give it your best shot. Okay, we'll give it about 30 more seconds. All right, I'm gonna end the poll now. So let's go over that one. So can anyone tell me the formula that they used? Or what formula we should use? All right, so it's just the same as the last one that we used. We just want to have n minus 1 on the bottom. So the sum of x squared minus the sum of x squared. Should I use capital N or lowercase n?
Excuse me, capital.
Good, yeah, thank you. Capital N divided by n minus 1. Good, okay. So let's start by doing it the same way we did the last one. So let's find the sum of x squared. So we would need to square them all and then add them up. So 10 squared plus 12 squared plus 16 squared plus 13 squared plus 19 squared. So can anyone tell me what they got when they plugged that into the calculator? Smaller number than the last one. Good, 1030, perfect, 1030. Okay, so let's do the next one. So the sum of x squared. So that means we need to add them all up and then square it. So 10 plus 12 plus 16 plus 13 plus 19 equals. So can anyone tell me what that is? We already did it.
180.
Yeah, so that's when you square it. So before it should be 70, right?
Or sorry,
Yeah,
yeah.
you're good, you're good. 70 squared, and
90.
you said
Go ahead.
980. or sorry, before that, 4,900, good, yeah, sorry. Yes, perfect, thank you, okay. And then what was our n? Can anyone tell me what our n should be? So how many were in this, how many scores are there? 5, good, okay. So we have everything, so let's just plug everything in. I'm gonna move this a little bit out of the way so I have extra room to write. Okay, so the sum of x squared we said was 1030 minus, so the other sum of x squared we said was 4,900 divided by 5, and the whole thing divided by 5 minus 1. Okay, so I believe someone said it already that this part was 980. So 1030 minus 980 divided by 4. Okay, so can anyone tell me what 1030 minus 980 is?
I got 50,
50, good. And then 50 divided by 4,
12.5.
12.5. Perfect. So that is our answer. So does anyone have any questions on how we got there? No? Okay, let's do the standard deviation. So that one is another poll. Hopefully, I forgot to end that last one. Oops. Oh well. Okay. Standard deviation. Let's do it. What was that? Did someone have a question? No? Okay. Okay, let's give it like 15 more seconds. Awesome. Let's end that. So everyone answered, got it right. So can anyone tell me how they found it or how they think we should do it? So all we need to do is take the square root of the variance. So we said that our variance was 12.5, so the square root of 12.5. Anyone want to shout out what they got or type in the chat? What the square root of 12.5 is? Good, 3.54. Perfect, that's our answer. So does anyone have any questions on that problem or anything before we move on to z-scores? Okay. I'm gonna send everyone those links again, just in case anyone has to leave early. I'm gonna send those links because I want everyone to make sure that they're able to get this, have access to it. Okay, let's move on to z-scores now. So let's start with this first problem. So the grades on a psychology exam had a mean of 83%. The standard deviation for this exam was 2. Allie scored an 89 on the exam. What is the z-score for Allie's exam? So let's first start. Can anyone remind us what the equation for the z-score is?
It's x minus sample mean over standard deviation.
Perfect, good, thank you. Over standard deviation, thank you. Okay, so let's work this problem out. So can anyone tell me what this first x should be, what we should plug in?
$89.
Good, yes, 89, okay, and what was the mean?
83.
83, perfect, and what about the standard deviation?
2.
2, yes, thank you, okay, so 89 minus 83 should be 6 divided by 2, and that's 3. So that is our answer right there. Does anyone have any questions on how we got there? Before we move on to the next one. The next one you guys is gonna be a poll, so I'll have you guys try it on your own. No questions? Okay, let's try the next one. So let me start the poll. All right, let's go ahead and try that one. All right, let's give it like 20 more seconds while you guys are answering. I'm putting my laptop in really fast.
Sorry, my laptop is glitching for a second.
No, you're good, no worries. We're about to die, so. Okay, plugged it in, we're good. Okay, let's give it like 10 more seconds. Get our answers in. Okay, I'm gonna go ahead and end the poll now. So everyone that answered got it correct. Good job, everyone. Okay, so let's go over it. So we're gonna be following the same equation. So x minus the mean divided by the standard deviation. Okay, so can anyone tell me what they put for the score? That first x? $300,000, perfect, yes, 300,000. Okay, and what about the mean? 455,000, yes, thank you. And the standard deviation, anyone?
$20,000.
Yes, good, 20,000. Okay, can anyone tell me what they get when they subtract 300,000 from 455,000?
Negative 155,000.
Negative 150,000. Oh, no, sorry. Okay. Divided by 20,000. Okay, and then what do you get when you divide those two? Oops, sorry. This should be 155,000, my bad. Okay, good. Negative 7.75. Good. So can the z-score be negative? Or does it always have to be positive?
It can be negative.
Good, yes, that's a trick question. It can be negative. So that is our answer. So does anyone have any questions on those two before we move on to the next page? No? Okay, let's go on to the next one. So a sample of n equals 15 scores is obtained from a population with a mean of 112 and a standard deviation of 3. If the sample mean is 110, then the z-score of the sample mean is blank. So this one is a little bit different for the equation we're going to be using. Does anyone know the equation we'll possibly be using?
Isn't it the x minus the mean divided by the standard error?
Yes, so that's, yes, very close. You have everything right. It's just, so it's gonna be the sample mean. So I'm just gonna abbreviate X bar, sample mean minus the population mean. Divided by the whole thing, divided by the standard error. Good, good job. Okay, what about standard error? Can anyone tell me how we calculate standard error? The equation for that?
Is it the standard deviation divided by the square root of n?
Yeah, perfect. Good job. So standard deviation divided by the square root of n. Perfect. Good job, everyone. Okay, so let's try our problem out now. So let's start by finding our standard error, right? That's the first thing we need to do. So we said our standard error equation is standard deviation divided by the square root of n. So can anyone tell me what the standard deviation is for this problem?
3.
3, yes, so 3, and then we need to divide by the square root of n. So what is n?
15.
15, yes, which brings me to, so it's lowercase n, what does that mean? Anyone?
It says population.
Yeah, good, okay, good. Well, let's do this now. So 3 divided by the square root of 15. Can anyone tell me what they get when they plug that into their calculator? Good, 0.77. Good, 0.77. Awesome. So now we just need to plug everything into our top equation. So the sample mean minus the population mean divided by standard error. So what's the sample mean for this equation or this problem? $110, good. 110 minus, okay, what's the population mean?
112.
112, good. And then we said our standard error was 0.77. So when we plug that in, it should be -2 divided by 0.77. So what is that when you plug it into your calculator, anyone? -2.6, perfect. So for these ones, we'll just do 2 decimal places. So it'd just be -2.58. Good. Thank you. everyone. Yep, go ahead.
I was lagging a little bit. So what are we trying to find right now? Again?
So we're still doing the z-score. This is just a different problem. So it has to do with sample mean and population mean. So we're just using these 2 equations that we wrote up here on the top in red. We're still finding
So-
this, of course.
Okay, so we're trying to. Okay.
Of course, yeah. Thanks for asking, clarifying. Okay, so is everyone ready to move on to the next one? This one's going to be a poll, so you guys are going to try it out for yourself again. Okay, let me start the poll and then I'll have you guys try it out. Okay, let's try it.
Wait, so the X with the dash on the top is mean for both sample and population?
So there's 2 separate ones in this problem. So this one would be sample mean minus population mean. So if you look back to the one we did in the first one, we said population with a mean of 112, that was our population mean, and then sample mean is 110. That would be our sample mean.
No, I meant like the sign for X with the dash on top.
Oh
It
yeah,
can mean,
that just means mean.
okay, so you can never know which one it really means if they ask you that.
In this case, there is a different symbol for the difference in sample mean and population mean. So like X bar versus like mu. So this one usually means sample mean, and this one usually means population mean.
Okay.
But just for this one, I just wrote it out that way. So it's a little bit easier. Okay, let's give it about 20 more seconds. Thank you for asking questions, by the way. Appreciate it. I'm sure everyone else is wondering the same thing. So if anyone else has questions, feel free to ask. Okay, I'm gonna close the poll now. So everyone answered, got it correct. Good job. So let's go over it. So let's start by finding our standard error. So what was the standard deviation for this one? $11, good, 11. And then what was the number of samples? So N.
57.
57, perfect, thank you. Okay, can anyone tell me what they get when they divide 11 by the square root of 57? We'll just do 2 decimal places for this. Good, 1.46. 1.46, okay, now we have everything we need, so let's plug it in. So what's the sample mean for this one?
120.
120, and what about the population mean?
123.
Good, divided by what we just said was the standard error, so 1.46. So it should be -3 divided by 1.46. Can anyone tell me what they get when they divide those two?
I got -2.05.
Good, -2.05. Good job. That's our answer. Perfect. Okay, does anyone have any questions before we move on? We're going to move on to different types of Z-score problems after this. No? Okay. So now we're going to be doing probability having to do with Z-score. So for this problem, it says for a normal distribution with a mean of 88 and a standard deviation of 3, what is the probability of randomly selecting a score greater than 91? Okay. So the first thing we need to do is just find the Z-score. We're going to be going back to our old equation. So the one where X minus this mean divided by the standard deviation. We're just going to go back to that equation for these. So can anyone tell me what the score is, the first X from this problem?
91.
Good, 91. And what's the mean? 88, perfect. Divided by, what's the standard deviation?
3.
3, good, okay. So let's plug that all in. So 91 minus 88 is just 3 divided by 3. So that's just equal to 1, right? So what we need to do now is go to the Z table and find our score on the Z table. So I have the Z table on this one right here. So this, we have a, so does this table not look familiar to anyone? And I can explain like how to read it and everything if it does not look familiar to someone.
Yeah, can you, I mean, it looks familiar, but I remember I had a question on this one about.
Yeah, I can, of course, yeah, I'll go over it. So there's two, I don't want to like make you guys like sick by scrolling back and forth a bunch, but there's two different tables. So if your score is positive, we want to use this table. If your score is negative, we would want to use this table. So our score is positive, so we're going to use this table right here. So what you want to do to find a score, so let's use our example. So we said our score was 1.00. So we want to find that number on our table. So the first thing you want to do is come to this side down here on the left. And we want to find, let me highlight. We want to find this part, the yellow part that I highlighted on the number on that chart. So let's go to find that. So we would go down to 1.0. So that's right here. So the next thing we want to do, let's use this color, is go to this side of the chart. So we want to find this part on that chart. So we just want to go and find where they meet. So we see the 0, 0s here. So we go down to where they meet, and that would be this. Let me change to this color. That would be this number right here. Now let's say, for example, we have one that's not quite that easy. So let's try it on a different one. Let's try it on 2.76. So we'd want to go to find on this part right here, we'd want to go to find 2.7 first. So let's go down till we find 2.7. That's right here. Oop, let me draw the line lower so it's not cutting off. That would be right here. So the next thing we want to do is find those 0.06 on the chart. So that's right here. We just want to go down to where they meet. So that would be this number right here, 0.9971. Does that make sense? Does anyone have any questions on that?
When she's testing us, will it be these two charts or something similar?
Who is your professor?
Generva, I don't know how to say her last name.
Okay, so I know that some professors give you the Z table and some professors ask you to do it on a calculator. I'm not sure if your class is one that uses the calculator or uses the table.
I think it's in table.
You use the table? Okay, then yeah, she'll definitely provide you with this table because it's definitely not something you would have to memorize. There's no way you can memorize this.
Okay.
So it would be given to you, yeah. There's no way you'd memorize that. Okay, someone
And
asked
then,
again. I'm just gonna send those real quick. Go ahead, I heard you have a question.
Yeah, so are you gonna teach us how to calculate on calculator, or this will be enough?
So unfortunately, I do not have that calculator, so I can't teach you how to do it that way, but I can teach you how to do it by hand. Yeah,
Oh,
sorry about that. But if you have questions about how to do it on the calculator, I'm sure your professor would be more than willing to answer those. I just don't have that calculator, so I don't have the ability to go over that with you. But
there's a certain calculator.
what was that?
There's a certain calculator you need.
Yeah, you have to have like I believe it's like the TI-84 or something that's comparable to that. I don't have that. I just have like a normal like scientific calculator. So my calculator does not do that.
Okay, got you. And this would be like the probability, like finding this would be like the probability of something.
Yes, exactly. Good questions, everyone. Okay, so we found our value on the table. That was this 0.8413. So let's go back to this now. So I'm going to write, so our Z table value. So this is just how I'm going to signify the value we get from the table. Our Z table value was 0.8413. Okay. So that is a probability, but we need to look at something from the problem. So our problem says greater than 91. So there's a general rule. I'm going to write the general rule that you want to use to determine if you're done, if that's your answer, or if there's something else we need to do. So if the problem says greater than you would want to do that 1 minus the value you get from the table. So 1 minus z table would be your answer. If it says less than, your answer would just be the value you get from the z table. That would be your probability. So R says greater than 91. So we want to do 1 minus that value. So it would just be 1 minus 0.8413. Okay, can anyone plug that into their calculator and tell me what they get? It's going to be like a small decimal.
Wow, that makes a lot of sense. That's why I got it wrong.
Good. I'm glad it makes sense. I'm glad. Good. Okay, I saw the answer 0.1587. So that's our answer. That's our answer. Does anyone have any questions on how we got there? So the next one you guys are going to try on your own.
Will we have access to the Z tables to do the next one?
Yeah, I'll scroll to the Z table on the on my iPad. I'll scroll to the Z table. And if anyone needs like a link to a good Z table, I could send you guys a link to that as well. Just comment like yes in the chat or I want the link or something, and I'll send you guys a link to that. It's the same one that I'm using on here. These are just screenshots of it. Okay, let's move on to the next one. Yes, okay, let's move on to the next one while you guys are working on that. I'll get the link for you. So this one is a poll, so let's do it. Let's try it. Just pay close attention to if it says less than or greater than. Okay, let's try it. And while you guys are trying it, I'm going to get the link to the Z table. Oh, sorry. I realized I said I would scroll. I'm going to give like 15 seconds just for everyone to like write down the numbers, and then I'll scroll to the next one. And here's a link to the Z table. If anyone wants to use that now, they're more than welcome to. Okay, I'm going to scroll to the Z table now. So let's see. Oop, that's really zoomed in. Okay. Should be using this one, because remember, if you get a negative number when you plug the formula in, you need to use the negative Z table. There's a negative Z table and a positive Z table. I want to make sure you use the right one.
It said less than 3, right? I just want to make sure.
What was that? Sorry.
It said less than 3, right? Or 30.
Less than 33. So it said a mean of 36, a standard deviation of 2, and a score of 33. Okay, I'm going to give it about 30 more seconds before we go over it. Okay. Good. So everyone that answered got it correct. So let's just go over it. So let's see here. Let's go back to our problem. Okay, so let's plug everything into our formula. So what is the first x? What value should I write down? 33. Good. So 33. And then what was our mean? 36. Thank you. And the standard deviation? 2. Perfect. So when you plug that all in, what do you get? Negative 1.5. Good. Negative 1.50. Okay, so let's go to our table. Find that. Okay, so our value was 1.50. So let's find it on the left, or sorry, negative 1.50. Let's find it on the left, so negative 1.5, and then the second number, or the second decimal was 0. So we'll go to where those meet. That should be this number right here. 0.668. Okay, scroll back. Sorry, it's a lot of scrolling. I don't want to make you guys like all sick. Okay, so we got 0.0668. Okay, so it says less than. So is that our answer, or do we need to subtract from 1?
That's the answer.
Good, yes, so that's our answer. So let's say, for example, if it had said greater than, so I'm just gonna write greater than, what would we do? What should we do?
We would go 1 minus 0.0668.
Good, so 1 minus 0.0668. Can anyone plug that in real quick and tell me what they get? It's a really small number, I know. Or not really, it's not super smaller than 1. Okay, just for time, I'm just gonna write it. So 0.9332. Good. Thank you, Carolina. I saw your answer in the chat. Okay, does anyone have any questions on that before we move on? No? Okay. So let's do this problem. So a normally distributed population has a mean of 40 and a standard deviation of 4. What is the probability of randomly selecting a sample of size 9 that has a mean greater than 42? Okay, so this one is a little bit different. So we need to find, so this problem is the probability that the sample size is 9 and that it has a mean of greater than 42. So we're going to combine the two problems that we did before. So the first thing we're going to do is we're going to use this equation. So the score minus the mean divided by the standard error. Okay. Okay. Sorry, I'm looking at what I did on here. I don't think it's right. Okay. So I think I did it with an old number. So yes, I did. Okay, so what we're going to be doing is actually we're going to be using this equation that we used up here, the sample mean minus the population mean divided by the standard error. So we're going to find that equation first to find that standard, that z-score. So what is the sample mean? The sample mean for this problem. Sorry, cut it off a little bit. 42, good. 42. And what's the population mean?
40.
40, good. You know what? I did not do, okay, let's just rewind, sorry. I don't want to, I'm confusing myself, so I know I'm confusing you guys. So this is the equation that we're going to use once we find the standard error. Now I see where I confused myself. Okay, so this is our equation that we're going to use. So it's just the score minus the mean divided by the standard error. So the first thing that we need to do is find standard error. So let's start with that. Sorry, everyone, confused myself. Okay, standard error. So if we remember correctly, the equation for standard error was the standard deviation divided by the square root of n. So our standard deviation, we already said, was 4. So what would be n?
9.
Good. Okay, can anyone plug that into their calculator and tell me what they get? $1.33. Perfect. Thank you. 1.33. Okay, so now we have everything. We could plug it into our first equation. So what should x be? Our first x.
42.
Yeah, good. 42. And then what was our mean?
40.
40. Good. Okay, divided by, and then we just divide by the standard error, which we already said was 1.33. So that's just going to be equal to 2 divided by 1.33. Okay, can anyone plug that in for me and tell me what they get? Good, 1.50. Okay, so now we just need to plug it into our z table. So let's go ahead and look for that on our z table. So we're going to use, should we use this chart or the other chart?
This chart.
Good, yes, thank you. Okay, so let's find it on here. So I'm gonna have you guys try and find it and tell me what you get. So we're looking for 1.50 on here. I'm gonna write this in a different color just so I could box it. Has anyone got what it should be?
Isn't it 0.9332?
Yeah, good. So 0.9332. Let's just box that. Good. Okay, so let's go back now. So we said our z table score was 0.9332. Okay. So is that our answer, or do we need to do anything else?
We need to subtract 1 minus 0.9332.
Good. And why is that?
Because it's greater than.
Good. Thank you. So 1 minus 0.9332. Okay. Does anyone have know what that would be when you plug it in the calculator?
Why is it greater than again?
So in this problem, it just the problem itself says greater than right here.
Oh, I see.
And then when we go back, we just remember that greater than means 1 minus that value. Great. Okay. Did anyone put that in and get a number?
0.0668.
Good. So it's pretty much exactly what we did on the last one, just opposite. Okay. So that's our answer now. Does anyone have any questions on how we got that? Before we move on? Okay, let's move on. I'm gonna scroll a lot to get to the next one. Sorry, guys. Okay. So the last two problems for z-scores we're going to work on. So let's see here. So the average IQ score is 105. The standard deviation for IQ scores is 9. What proportion of IQ scores are between 95 and 110? Okay. So what we need to do here, we're just going to use our old equation. So the one that says x minus x bar mean divided by the standard deviation. Okay, so what, does anyone have any idea of what we should do, what they think we should do? I just realized we have like 10 minutes left. I'm so sorry, guys. Okay, let's just go through this one really quickly. And then I want to go over really quickly the hypothesis testing. So everything else that we don't cover on the worksheet, it's going to be on the answer key when I send it out to you. And if you have any questions, just schedule an appointment with me and we could go over it. I'm sorry, I didn't realize it was going to take this long. So let's just go over this one really quickly. So so we just need to find the z-score for both values. So we need to find the z-score for 95 and the z-score for 110. So let's start with z of 95. Okay, so our score would just be 95. So what would be the mean?
105.
105, good. And what about the standard deviation?
9.
9, yeah.
9, thank you both. Okay, so when we plug that in, it's just 10 divided by 9, right?
Mhm.
Okay, or negative 10 divided by 9. So that is equal to negative 1.11. Okay, so now we just do the same exact thing for the 110 score. So z of 110. So we would just do 110 minus 105 divided by 9. So that should give us 5 over 9, right? Okay, and when you divide those, 5 divided by 9, what do you get?
0.56.
Good, thank you, 0.56. Okay, so now we just need to go find those values on the z table. So let's start with this table. So this is our negative table. So we are looking for on this table. What was that? Did you have a question?
Oh, no. sorry.
No, it's okay. Okay, so we're looking for negative 1.11. Can anyone find that on the table?
It's 0.1335.
0.1335. Yes, right here, 0.1335. Perfect, good. So let's write that down. So we found our z table value was 0.1335.
So
Good.
whenever asked about proportions, then we go to the z table.
Yeah, so if it asks for proportion or probability, you want to use the z table. Okay.
Thank you.
Okay, so let's do our other one. So 0.56. So let's try that one on here. Can anyone tell me what they get? Okay, so we go to 0.5, which is right here. And then we go to 0.6, which is right here. We just go to where those meet. So it should be 0.7123. Cool, so let's write that down. So z table would be 0.70, sorry, I don't remember. Mm, 0.7123. Okay, so all that we need to do now is just subtract them from each other. So we just want to, you always subtract the biggest number from the smallest number. Oh, I see someone raise their hand. You could go ahead and ask your question.
I was just wondering if you were going to go over confidence intervals.
So we only have 5 minutes left, unfortunately. I did have some questions that were on here for confidence intervals. but we won't have time to go over it. So if you want, you could schedule an appointment with me. I'd be more than happy to explain confidence intervals, and I can make some problems up too to go over that. But unfortunately, we only have about 5 minutes left, so we don't have enough time.
Yeah, but okay, then can you tell me after this ends how to schedule the appointment?
Of course, yeah, I'm more than happy to do that. Okay, so let's just finish this one up. So we would just subtract the biggest from the smallest. So we would just do 0.7123 minus 0.1335. So when we plug that in, can anyone tell me what you get?
Uh, 0.5788.
Good, 0.5788. Okay, so that's our answer right there. Okay. Does anyone have any questions on how we got to that? No. Okay. I'm gonna send the links to those surveys again. I'm gonna stay and finish up just going over the alternative and null hypothesis. So if you guys want to stay, you're more than welcome to. If you don't want to stay, that's okay as well. So I sent those links out. Just make sure you fill out the survey so I can get your email to send you all these documents. And when I send it to you, the documents will have the answers to all the stuff that we didn't have time to cover. Yes. Okay, let's do some hypothesis testing real quick. Okay, so all we're going to go over for hypothesis testing is how to write the alternative and null hypothesis. So we're just going to go over one example. Okay, so this question says, a researcher wants to determine if there's a positive relationship between sending and receiving text. He uses the following data. The data doesn't really matter too much for this. So can anyone tell me like what the definition of an alternative hypothesis is?
An effect.
Yeah, so that it says that there is some effect, something's happening. So based on that, let's write our alternative hypothesis. So that would be, there is a significant positive relationship. Normally you would write out the entire thing. I'm just going to write this just for time's sake because we are pretty much out of time already. But normally you would just say there is a significant positive relationship between sending and receiving text. But so in this problem, we want to include positive relationship because it does say right here in the problem, positive relationship. But for example, if it just said, if there is a relationship, we would just say there is a significant relationship. We wouldn't need to say positive or negative unless they say that specifically. Okay. Can anyone tell me what the null hypothesis is?
That there's no relationship.
Good. So yeah, so exactly what you said. So we would just say there is not a significant positive relationship. Okay, perfect. So now the statistical hypothesis is just writing it in number forms with like P and numbers. So let's do that. So HA, which stands for alternative hypothesis. So HA, I'm going to write it above, and then null is HO. So HA and HO. So the null is always going to be either, well, it's pretty much always going to be P is equal to 0, because that's saying that there's no relationship, right? But the alternative hypothesis can either say P is greater than, it could say P is less than, or it could say P is not equal to a number. So for this one, does anyone know if it should be P is greater than, P is less than, or P is not equal to?
P is greater.
Good, yeah. Why do you say P is greater than 0 would be the answer?
It says positive.
Good, yeah, perfect. Good job. Okay. Does anyone have any questions on that before we move on? We're just going to go over error types next. There is another example of alternative and null hypothesis, but that will be on the key that I send you guys. Okay, let's go over the error types. So there's two error types, right? There's just type 1 and type 2. Okay, so can anyone tell me which error would be associated with rejecting the null hypothesis?
Would that be type 1?
Good, yeah, type 1. Good, so anytime, oh, that's really close. So anytime you reject the null, it's going to be a type 1 error. Or could be a type 1 error, but it's always going to be associated with a type 1 error, always. So that would mean that if we retain the null, so another way of saying retain would be fail to reject. I know some professors use that terminology instead of retain. They mean the same thing, but that would be a type 2 error. Always. Okay, does anyone have any questions about that? Sorry, I just realized I look like I'm telling scary stories, like super dark. Okay,
I had a question about the z-scores.
yeah, of course, go ahead.
What
Yeah,
was the
that makes
difference
sense.
between z-scores and one sample z-tests?
Sorry, what was it? One more time.
What was what's the difference between finding the z-score and one sample z-test?
So are you asking like what's the difference between like just finding a z-score and then having to find it on the z-table?
No, I just wanted to know if there was a difference between finding the z-scores and finding the z-test.
Not sure, but I think you might be muted.
Oh, am I muted?
No, I can hear you.
Oh, okay.
Between one sample z-tests and z-scores, like what's the difference? Or do you need to find the z-score in order to be able to do the one sample z-test?
Yeah, so you need the z.
Oh, I see,
find
okay.
The z-test. Yeah, so we use that z-score to plug it into the table to get our z-table value, right?
Oh, I see, okay. Okay, cool, thank you.
Yeah, of course. Okay, so that's all we have time for. So here's the links just one more time.
Thank you so much.
Yeah,
That has helped a lot.
good, I'm glad. If you have any other questions or like you want to go over something specific or go over anything that I send you from the answer key, feel free to make an appointment. I'm gonna go back to that. Sorry, this is a lot of scrolling.
Do you have any appointments available?
Yeah, so I have pretty much like all my appointments are available except for I have one appointment scheduled on Friday from 9 a.m. to 10 a.m., but all the rest are open.
How do I make an appointment?
So you just follow these instructions. I'm just gonna zoom in right here. So you would go to Spartan Connect and then you would just click on the appointments, drop-ins, and workshops button. And then you would just fill in like your information and then just make sure you click on CHHS Student Success Center at MQH and then it'll pop up with like all the available appointments. You just select an appointment and schedule it that way. And so if you have like any issues with this and it doesn't work, send me an email and I'll try and help you out or try and get like the front desk staff to schedule the appointment for you. I'm gonna put my email in the chat just in case that is the case, it doesn't work for you. You could send me an email. You'll have my email anyways when I send you all this information. But just in case it does not work.
So right after the survey, you'll send it all?
Yes. I have to like probably give me like about 30 minutes, but yeah, it'll be right after this. Yeah. Okay, I'm gonna stop the recording real quick.